Hello, my dear students. Very good morning to all. Hope you are all doing good. Thank you so much for the excellent cooperation and response you are giving for the video lectures. I'm so happy about that. Today we are going to discuss about a topic related to energy. Since the whole world is running behind energy, it is interesting to discuss the same now. Renewable energy sources. In the past few decades, we are utilizing so much of fossil fuels like coal and petroleum and other derived products, and those energy sources are non-renewable or they are not generated in a particular time period, and they are exhaustible and highly polluting. So to make the earth clean, green and environmentally friendly, we have to move to some other alternative energy sources like solar, wind, etc. So they are collectively called renewable energy sources or alternate or non-conventional energy sources. For example, renewable energy sources are the energy sources or naturally replenished or regenerated on a human time scale, and they are inexhaustible. In simpler way, renewable energy sources are the energy sources. They can be regenerated in a particular time duration. Example, sunlight, wind, waves, geothermal heat, etc. Similarly, a renewable energy source also means that it is sustainable. That is, the energy sources which cannot run out and they are endless. Also, we used to use the word alternative energy many times. It usually referring to the renewable energy sources too. And the sources of energy that are alternative to the most commonly used non-sustainable or non-renewable or conventional sources like fossil fuels, that is coal and petroleum. They are actually conventional or non-sustainable. Now we are shifting to non-conventional and sustainable energy sources. They are called alternative energy sources. And the energy demand or the energy need of our country is growing more and more every year. In the year 2015, we have utilized 701 million ton oil equivalent of energy, and in 2035 we will need 1603 million ton equivalent of energy, which means that 129 percentage of energy consumption will be there in India by 2035. And now we are utilizing more amount of non-renewable energy sources like coal, petroleum, natural gas, oil, etc. So we have to make that 129 percentage by utilizing renewable energy sources. And the 2018 electricity plan or national electricity plan decided that by 2022 we have to reduce the coal and we have to increase the renewable energy by 175 gigawatts. And by 2027, we have to reduce coal again and we have to increase the renewables by 275 gigawatts. So, which means that we are moving to cleaner energies or renewable energy sources. And one more reason to moving to renewable energy sources is the pollution created by fossil fuels, that is coal and petroleum derived products like petrol, diesel, etc. So burning of fossil fuels produces more amount of carbon dioxide, sulfur and nitrogen oxides, and also they are causing severe climate change, global warming and greenhouse gas emissions, and they are killing 7 million people every year. So to make our earth free from pollution and to meet our energy demands, we have to move to renewable energy sources. So for that, we are having various renewable or alternative energy sources like solar, wind energy, hydroelectric power, biomass, tidal, geothermal, and also ocean thermal energies. So these are the various possible cleaner energies available. Now we are going to discuss each energy in detail. We know that solar energy is nothing but the energy harvested from sunlight. So sun has two components of energy, the radiant light and heat. So we are going to convert this light and heat into thermal energy and electrical energy. So the conversion of solar energy into various possible forms depending on our utilizations. Solar energy is the non-polluting, cleanest and most abundant renewable energy available in our Mother Earth, and we can harness this energy for generating electricity, providing light and heating water for domestic or commercial purposes. How solar energy is harvested is mainly by photovoltaic or solar cells. The solar panels, you used to hear this word. So in the solar panels, when the photon falls on that, it kicks out the electron from the outermost orbital of the semiconductor and makes the electrons to pass through. How the solar cells or photovoltaic cells are working? So they are actually semiconducting materials that transform sunlight directly into electricity. We know that there are two types of semiconductors, p-type and n-type. So in p-type semiconductor, the germanium or silicon, they are actually tetravalent, and these germanium or silicon is doped with trivalent elements like boron. So hence a hole is created, that is a vacant orbital is created. In n-type, we are going to dope silicon or germanium with pentavalent elements like arsenic. It creates one extra electron. So here a positive hole is created, here an additional electron is there. So when p and n-type semiconductors are connected, when sunlight falls on the solar panel containing these semiconductors, it produces a barrier. So from the positive type semiconductor, the holes move and forms a layer. Similarly, from the n-type semiconductor, the electron moves and forms a layer. So a barrier layer is formed. As a result, a potential is generated called barrier layer potential. As a result, the electron and holes moving in the opposite directions, producing a complete circuit, and also electricity is generated. So this is how a solar or photovoltaic cell is converting the sunlight into electricity. And the photo conversion. So how the radiant light of sunlight is converted into various applications. For example, we are converting the radiant light of sunlight into street light by generating electricity and illuminating the lamp. Similarly, the solar water pumps are also produced, and also the electricity produced can power the vehicles, that is the electric vehicles. So likewise, the photo or photon of the sunlight is converted into electricity. Now we are going to see about how the thermal component of the sunlight is converted. Here we always used to see the water heater in the rooftops of many buildings. So it contains n number of copper tubes which is actually placed inside a chamber. The above surface is made up of glass which absorbs more amount of heat, and it makes the copper tubes to get heated. So we are going to pass the cold water through this copper tubes which is already hot due to the sunlight, and it will make the water hot by transferring the heat. So now the hot water is produced. There is no bigger principle involved in this. So just transfer of heat from the copper tubes to the water. Similarly, in cold countries or hill stations, the houses need to be warm in the night time. So for that they will be having bigger glass windows and more amount of sunlight will be allowed to enter into the house, and they will be insulated so the sunlight will not leave much easier. So the thermal radiations are produced and they will be inside the house only. So likewise the heat is collected. So the house or the room will become very much warm compared to the external temperature. Now we are going to discuss about the wind energy. So wind energy is also another form of solar energy because the sun heats the air and makes the air to move. So hence it is called wind. So wind energy is nothing but the kinetic energy of air in motion, also called wind. The energy harnessed from moving air or wind is called wind energy. In 2018, we have produced 591 gigawatts of wind energy worldwide, and also India produced 35,000 megawatts of wind energy by 2019 September. So our target in 2022 is 60,000 megawatts of electricity through wind energy. And Tamil Nadu is the highest producer of wind energy in our country. So it shows that the amount of electricity produced through wind energy is alarmingly increasing, and it is also a good sign. And how windmills are working. The kinetic energy created by air in motion or the wind is actually transformed into electrical energy using windmills or wind turbines. So the wind first hits a turbine blade and then causing them to rotate, and then the turbine connected to them. So for example, the blades are actually rotating due to the wind hit and it actually rotates the turbine. So this changes the kinetic energy to rotational energy, and by moving a shaft connected to a generator and producing electrical energy through electromagnetic induction. So inside two strong permanent magnets, the shaft is being rotated, and through the principle of electromagnetic induction, electricity is produced. So what are the various possible power production in windmills? So the output is highly calibrated, which means that the dimensions of the rotor actually affects the output, and the output is proportional to the dimensions of the rotor, and it is actually proportional to the cube of the wind speed. And the amount of power harnessed depends on the size of turbine and length of its blades. Theoretically, when wind speed doubles, the wind power potential increases by a factor of 8. So that is, the output is proportional to the cube of the wind speed. And the various possible wind energy harnessing equipments or designs are wind farms. They are nothing but windmills connected in series. Similarly, ladder mill, sky cells are some other forms of wind energy harnessing designs. Now we are going to see about ocean thermal energy. So this is the energy produced by using the temperature difference between the various ocean currents. For example, the deep ocean is actually very much colder, whereas the tropical surface waters of ocean is warmer. So due to the difference in temperature, we are going to harvest the difference in temperature as energy. So that is called ocean thermal energy conversion. So here this picture shows the decrease in temperature when the depth of the ocean is getting increased. So the ocean thermal energy conversion plants pump large quantities of deep cold seawater and surface seawater to produce electricity. So it is actually a firm power, that is we will produce it 24/7, and it is actually clean, sustainable and capable of producing massive levels of energy. How the OTEC is working? Here you can see. So The temperature difference in the surface water and deep ocean water is utilized here. Actually, a working fluid is used here to convert the heat of the surface water. For example, ammonia is usually used as working fluid because its boiling point is around minus 33 degrees Celsius. That is, even a small rise in temperature causes ammonia to evaporate, ammonia liquid to evaporate, and the ammonia vapors are allowed to make the turbine to rotate, and which in turn is connected to the generator which produces electricity. For example, here you can see the working fluid is in a cycle, and in the left side you can see the red color liquid flowing is the surface water which is higher in temperature, which actually makes ammonia to evaporate and makes it to force on the turbine. So once the rotation of turbine is finished, the ammonia is getting collected again as liquid, and again it is made to go to the same place where it is converted into vapor. So this process is a cycle. At one side, the hard surface water is used for vaporizing ammonia. At another side, the vapor ammonia is condensed to liquid ammonia using the cold waters. So we are utilizing both the waters to make the turbine rotate and produce electricity. So here the ammonia is evaporated using the hard surface waters, and the turbine is rotated because of the ammonia vapor, and then the vapor is condensed by the cold waters of the deep ocean. So this is how the ocean thermal energy is converted or utilized. The next one is, this is also ocean energy but tidal power or tidal energy. So instead of temperature difference, here we are going to use the kinetic and potential differences of the various tides. So tidal power is the form of hydropower that converts the energy obtained from natural rise and fall of the tides into useful forms of power, mainly electricity. So we know that the natural rise and falls of the tides is happening all the time, and this is because of the periodic changes in the sea level caused by the gravitational influences of moon, sun, and the rotation of earth. So because of this, the tides are moving up and down, or they will rise and fall. So as a result, that kinetic energy is harvested into electricity. So how it is harvested is very much interesting. Here you can see that the tidal power is having two forms, the dynamic energy of the sea currents and the potential energy due to the change of water levels. The dynamic energy can be made use by the turbines or fences in the tidal stream system, which means that by analyzing the dynamicity of the tides, we have to make tidal turbines or tidal fences. So based on the rotation, we will generate electricity through the principle already available. Or if there is a difference in the potential energy of the tides, then the dams are generally required. So these are called barrages. A barrage is usually built at the estuary to separate the fresh water from the sea. So estuaries we have already discussed in the ecosystem. So when a freshwater ecosystem is meeting a saltwater or marine ecosystem, then that portion is called estuarine ecosystem. So at that place, they will construct a dam-like structures, and they will place turbines. So when the water flows out from the ocean, it will make the turbine to rotate. Similarly, when water enters from this side also, the turbine will rotate and produces electricity. So this is how the dynamic energy of the sea currents and the potential energy due to the change of water levels is harvested into electricity. Now we are going to see about another interesting renewable energy source, geothermal energy. So usually the earth surface is much cooler compared to the earth crust. The inside of the earth we will have huge amount of heat. That is, Geothermal reservoirs are pools of water heated by magma deep below the surface. Water or steam can escape from cracks in the earth in the form of geysers. In California, you can see a number of geysers, natural geysers, and the ability to harness the steam is what powers a geothermal power plant. So since the magma makes the water to convert into either hot water or steam, so this hot water or steam is utilized in electricity generation. So hence it is called geothermal energy. So geothermal energy is the heat derived within the subsurface of the earth. Where the heat is from? It is actually contained in the rocks and fluids beneath the earth's crust and can be found as far down to the earth's hot molten rock, that is the magma, what we have discussed here. So the water or steam carry the geothermal energy to the earth's surface, that is in the form of heat. So depending on the characteristics, geothermal energy can be used for heating purposes, simply for heating purposes, or they can be harnessed in the form of electricity. There are three types of geothermal power plants available: dry steam, flash, and binary. We are going to see that in detail. First, dry steam power plant. Here, we are simply utilizing the hot steam which is produced from the earth crust, and this hot steam is forced to rotate the turbine. So directly the hot steam is passed over the turbine which generates power. And the next one is flash steam power plant. Here the hot water from the underground is pumped into a cooler temperature flash tank. So here we are not going to pass directly the steam. Instead, we are going to pass into the flash tank where some other fluid is present. So where this hot water makes the liquid to convert it into steam, and that steam is passed over the turbine. So here the hot water, instead of hot water, we are simply forcing the steam to pass through. Here we are converting some other liquid into steam and we are passing this. In binary cycle power plant also, we are converting a liquid into a low boiling liquid into steam and we are passing that and we are making the turbine to rotate. So the main difference is here we are utilizing the steam directly without any fluids or liquids, hence it is called dry steam power plant. In this case, we are making the hot water pumped into cooler temperature flash tank. Then the change in temperature causes the steam and it creates steam which is helping in running the turbine. Here, a low boiling liquid is converted into steam and which is made to pass through the turbine and which generates electricity. So these are the various possible geothermal power plants by which the heat or the steam is converted into electricity. Now we are going to discuss about the biomass energy. We are actually utilizing the biomass energy in larger quantities, and now instead of burning the biomass into simply making poor fuel, we have to convert the biomass into an efficient fuel by converting it into electricity or by combusting them in controlled manner. So biomass energy is nothing but energy generated or produced by living or dead organisms. So the most common biomass materials used for energy are plants such as corn, soy, etc. So the energy from these organisms can be burned to create heat or converted into electricity. So we can either directly boiling them and we are producing heat, or we will produce steam and make the turbine to rotate and generate electricity. So this is how biomass energy is converted into electricity, a simplest form. So in all the forms of energy conversion, it is mandatory to rotate the turbines, and we are making steams of various kinds to make the turbine to run. And thank you so much for listening, and it is an important topic we just looked into, not deeper. So simply we have a look into that. Kindly go through the video and refer some other possible materials, and we are having so many details available in the websites also regarding the renewable energy sources. Thank you so much. Have a good day.